Today we have a problem from MIT Integration Bee 2024 finals, and this was the first problem in the finals. Yeah, and regarding how do we solve this problem, the first approach, like in the obvious approach, would be like to try to express cos x in terms of this function, let's say f of x and its derivative f dash x. So that's the most basic approach if we have trigonometric ratios in numerator and denominator. So let's try to do that. Basically, we will try to express cos x in terms of some constant multiplied by the function, yeah, and then another constant multiplied by the derivative of the function, which is minus 3 sin x plus 4 cos x. Now after this we have to solve for a and b. That makes this statement true. So basically we will get 3a plus 4b should be equals to 1, yeah, for the coefficient of cos x and cos x to be equal to 1. And the next thing is 4a minus 3b should be equals to 0 because there is no coefficient of sin x. Now if you want to solve this, let's make the coefficient of a equal. We will have 12a plus 16b equals to 4 and 12a minus 9b is equals to 0. Now if we subtract second equation from the first one, we will have 25b equals to 4. That gives us b equals to 4 by 25. Now since the 25 matches with the answer, it seems like we are going in right direction. Yeah. And now we also have 12a equals to 9b, and b is basically 425, so it's 36 by 25, and hence a is 3 by 25. Yeah. And now let's try to write the integral in terms of the function and its derivative. Yeah. So we will basically have integral of e to the power x by 2, and then our a is 3 by 25, yeah, and then 3 cos x plus 4 sin x by cube root of 3 cos x plus 4 sin x, yeah, and then we will have plus, and then we will have plus, and b is 4 by 25 minus 3 sin x plus 4 cos x, yeah, and then we will have cube root of 3 cos x plus 4 sin x. Yeah, so this is our original integral, just that if you add the numerators, you will get cos x. Yeah. Now let us write this in more simpler form. Integral of e to the power x by 2, yeah, and now this is dot 3 by 25, and that can be written as 3 cos x plus 4 sin x to the power 2 by 3, yeah, 1 minus 1 by 3. And same in the same way, we have e to the power x by 2 times 4 by 25, yeah, and this can be written as 3 cos x plus 4 sin x to the power minus 1 by 3, yeah, and then the derivative, which is minus 3 sin x plus 4 cos x. At this point you begin to realize the form it is in. Yeah, basically if you just try to observe, here's we have 2 by 3 in the power, and if we differentiate this, the 2 by 3 will go to the forward, and we will have minus 1 by 3, and the derivative of these expressions, which is what we have here, minus 1 by 3 and derivative. So basically it seems like we can use product rule, and let's try to manipulate if this is in the form of product rule or not. Yeah, basically over here we should have the derivative of e to the power x by 2. Yeah, so e to the power x by 2 will be 1 by 2 times e to the power x by 2. Yeah, but now since we have added 1 by 2 over here, now we need to also multiply by 2. Yeah, and then we have over here 3 by 25. So like, okay, 2 times 3 by 25. Yeah, and 3 cos x plus 4 sin x to the power 2 by 3. Now over here we have e to the power x by 2 undifferentiated, and we have to differentiate this expression. Yeah, so we have 4 by 25, and now we need 2 by 3 over here to make this as a differentiated expression for the original expression. Yeah, and if we introduce 2 by 3, we also need 3 by 2. Yeah, and then this will be 3 cos x plus 4 sin x to the power minus 1 by 3, and then its derivative, which is minus 3 sin x plus 4 cos x, minus 3 sin x plus 4 cos x. Yeah, and then this is whole dx. Okay, and now here we have coefficient as 6 by 25, and the same thing is here. This is also 6 by 25, so that means it's in the product rule itself. Now we can take 6 by 25 common out. Yeah, and then this is just derivative of e to the power x by 2, and f of x, this is g of x, and again over here this is f dash x, sorry, and now this is f of x, and the other thing is g dash x. Yeah, so it's basically in the form f dash x g x plus f of x g dash x. Now this is exactly the product rule. Yeah, so that's why we can write this as f of x g of x. So we have 6 by 25 times f of x is e to the power x by 2, and g of x is 3 cos x plus 4 sin x to the power 2 by 3. Yeah, and don't forget the plus c after the integration, and this is the solution. So let's check the solution if it's correct or not. Yeah, 6 by 25, yeah, e to the power x by 2 is over here, and then 3 cos x plus 4 sin x, which is what we have over here, and those two are raised to power 2 by 3 exactly. So the answer is correct. Hope you enjoyed the solution. Thanks for watching, and look forward to seeing you in the upcoming videos too, where I solve problem 2 of MIT Integration B 2023.